So, now let us try to understand in detail regarding the next topic, that is mass as well as weight. So, next topic is all about your mass and weight. So, children, what is mass? The amount of matter contained in a substance is called as matter, mass. I repeat, the quantity of matter contained in a substance is called as your, or contained in a body is called as your mass. But what is weight? Weight is the force with which the body is pulled towards the surface of the earth. So what makes the difference means mass is the amount of matter contained in a body. Mass is the amount of matter contained in a body. But what is weight? Weight is the force with which the body is pulled towards the earth. The force with which the body, some body is there, some force is acting on that, and this is pulled towards the earth. And that itself is called as weight. So, mass itself is a scalar quantity. Itself is a scalar quantity, but whereas weight is a vector quantity. Mass is generally a SI system. It is measured in kg. Mass is measured in kg in SI system. But weight, let us indicate with W, which is equals to general formula, force with which the gravity is pulling. Force means formula mass into acceleration. When the gravity is acting on that, then the acceleration will be acceleration due to gravity, and this will be mg. So, the force with which the earth is pulling the body towards it is called as weight, and it is indicated with the letter mg, where m is the mass of the body and g is gravity. And units for this, SI units for this is, it might be kg meter per second square or simply Newton. So, what are the SI units? Kg meter per second square or Newton. Remember children, the mass of the body always remains constant. It only depends upon the amount of matter contained in it. But as we know that the value of G changes from place to place, the value of weight also changes from place to place. So, the value of W is different at different places. So, as the value of G changes from place to place, the weight of the body also changes from place to place. For instance, at the poles, the value of G is comparatively less. Okay. So, as we know that, so last class we have considered that the radius of the poles is lesser as compared to the radius at the equator, and since G is proportional to 1 by r square, then this implies that the value of G at poles is greater as compared to the value at equator. When acceleration due to gravity at poles is greater as compared to the acceleration due to gravity at equator, its weight is nothing but mgp at poles is greater as compared to the mge at equator. So, this implies that weight of a body at poles is greater as compared to the weight of the body at equator. So, weight of a body changes from place to place. If you consider at poles and equators, weight of the body at poles will be greater as compared to the weight of the body at equator. Similarly, at different places like sun, moon, earth and any other planets you consider, as the value of G changes, weight of the body also changes accordingly. Okay, children. So, these are all about the differences between mass and weight. Okay. So, one more thing I want to discuss, children. It's all about your Other practical units, kg weight. So what is 1 kg weight? So it is the practical unit or kg force. The value of 1 kg weight is equals to 9.8 Newton. How much is that? The value of 1 kg weight is equals to 9.8 Newton. The other name for kg weight is kg force. Whether you say it as kg force or kg weight, its value is 9.8 Newtons. This is an SI system. Similarly, if you want to discuss in CGS system, it is measured in gram weight or gram force. And its value will be gram into weight, and this will be something like 980 dynes. How much is that? Its value is 980 dynes. These are some other practical units we'll be using for weight. Okay. So with this, we have concluded with the chapter that is gravitation, children. So keep practicing. Let us meet in the next video. Until then, take care. Thank you.